Example 1. Part A. Suppose that a firm issued a 10-year, $1,000 par value bond with a 10% coupon rate that pays annual coupons. Assuming a YTM of 8%, what would be the fair price of this bond today? Part B. Consider a zero coupon bond that matures in 8 years. If the face value is $1,000 and the YTM is 6%, what is the market price right now? So in part A, we're dealing with an annual coupon bond. So the firm's going to pay these annual coupon payments for the next 10 years. And in part B, we have a zero coupon bond, which means the firm will not pay any coupon payments. It'll just pay the face value of $1,000 when the bond matures in 8 years. Okay, and par value and the face value, they mean the same thing. It's the final payment of $1,000 at the end when the bond matures. Okay, so we're gonna draw the timelines first. Example 1. Part A. So we have a 10-year bond. Okay. So if this were a 10-year semi-annual coupon bond, I'd be using 20 6-month periods. But here we have an annual coupon bond, so we use the regular 10 years. Okay, so everything is in years. Oops, I'll just erase this. Okay, so let me write down the details first. We have a coupon rate of 10%, and the par value is $1,000, and a YTM is 8%. Okay, so in my class, we talk about the M, right? So the M is either 1 or 2, depending on whether it's an annual coupon bond or a semi-annual coupon bond. So for all annual coupon bonds, M would be 1, and for semi-annual ones, M would be 2. Okay, and to figure out the annual coupon payment or the periodic coupon payments, we just do periodic coupon payment equals the coupon rate times the par value divided by the M. So the M represents the frequency of compounding per year. Okay? Since we're dealing with an annual coupon bond, compounding is done once per year. So we put in the numbers over 1, and you'll see that every year the bondholders will get paid $100. Okay, and let's move this down here. And we got to figure out the R that we'll use in the calculations, and that also involves the M. So the formula was YTM, yield to maturity, over M. And for annual bonds, YTM is the R. Okay? And you would adjust the number of periods, N, too. Okay? So that's just number of years times M. Okay? So in this case, as I mentioned earlier, we have 10 years and the M is 1. So we have 10 periods. Okay? So this would go here, and we'll use an R of 8%, and we can use this cash flow. Okay? So we'll fill in the timeline. So every year, bondholders will get $100, and it goes on for 10 years. But at the end of the bond, when the bond matures in 10 years, they'll get the face value of $1,000 too. Okay, that's the deal for bondholders. So based on this, we'll figure out the fair price of this bond. In other words, we want to get the present value of everything as of time 0. Okay? So we can just try to use the bond pricing formula, but I want to explain how it works. So first, we're dealing with two types of cash flows. So I'll just highlight the first one. So we have a regular annuity that goes on from year 1 to year 10. So I'll just write down annuity. It's a regular annuity. The amount doesn't grow. Okay? And then we have another cash flow pattern that occurs at the end of the bond, the $1,000. Okay? So obviously this is a single one-time cash flow. We'll call it a lump sum cash flow. So to calculate the present value of the bond, we want to calculate the present value of all of these cash flows. So to express this more formally, I'll do price of the bond today is equal to the present value of all of the coupon payments. That's the green cash flows, the annuity. And then we'll add the present value of the lump sum component. That's the par value or the face value. Par value of $1,000. Okay. So since we know what type of cash flow pattern we're dealing with, we can use the right formula. Okay. The first one, present value of the coupons, we already know it's a regular annuity, so we'll use the present value of an annuity formula. Okay, and that looks like this: coupons over R times this entire thing in the brackets, 1 plus R to the nth power. And then we have the present value of that one lump sum cash flow. So that is the par value will discount back to time 0. Okay. So just to make it clear, this formula is the PVA formula, present value of an annuity, and this formula is the PV formula of a lump sum cash flow. Okay, and then we plug the numbers in. Okay, so the price of the bond is then the coupon payments of $100 over the R of 8% times 1 minus 1.08 raised to the 10th power. Okay, so it's if we look at the annuity, let's look at the N real quick. The annuity is a 10-year annuity whose contract was signed in time 0. Okay, so the N is 10. And then we discount the $1,000 par value back to time 0, 1.08. Again, this is also to the 10th power. That's because this cash flow of $1,000 occurs in year 10. So when we take it back to time 0, you gotta take it back to time 0. You gotta discount it 10 years. Okay. So if you plug the numbers in, the fair price of the bond right now should be $1,134.20. That's part A. Okay? And we'll do part B. So part B said, Consider a zero coupon bond that matures in 8 years. If the face value is $1,000 and the YTM is 6%, what's the market price right now? Part B, you can do it here too. Part B, we have a zero coupon bond. So the timeline is pretty straightforward. Right now is time 0, and then we have a bond that matures in 8 years. Okay? And there's no coupon rate since it's a zero coupon bond, and the cash flow is very straightforward. You get the face value of 1,000 in 8 years. The YTM is given. YTM is 6%. Okay? So the R that we're going to use is also just 6%. So for zero coupon bonds, we'll assume that M is 1. Okay? So R is 6%. So the question is now pretty simple. If there's a security that promises $1,000 in 8 years, what's the fair price right now? Okay? So this is a very simple lump sum cash flow example where you're given a future value of cash flow that occurs in the future. You're given the N when the future cash flow occurs. Now we know the R, and we're just solving for the present value. Present value. Okay? So P0, price of the bond right now, is just the future value over 1 plus R to the nth power. That is 1,000 over 1.06 to the 8th power. And the correct answer should be 627.41. Parts A and B.